Assalamualaikum and very good afternoon to all of you. Okay, before we start our class today, so I have several announcements. The first one is on your assignment. Okay, so second assignment, which I have already shared with you in the WhatsApp group. Okay, so you need to carefully read the instruction. Okay. So what you need to do is just compile all the information that you have or that you read through the internet or other sources, and then compile it and make it as a mind map using Google. Okay, using Google. Okay, the deadline. So sorry, the group. Okay, so you remain the same group for the assignment one, and please be noted also for those who didn't cooperate. So the group leader can exclude their name. Okay, for the person that who did not do the work. Okay, just submit the name that already uh, cooperated during the assignment. Okay. Okay, the deadline. The deadline for assignment 2, okay? So since right now we are in a gray time period because we don't know uh, what should actually our calendar right now. So because last week suddenly the university postponed all the academics matters due to the flood. Okay, maybe because most of our students are affected. Okay, so they required that all the academics activities suspended. And right now we don't know whether the university will extend the academic calendar for 1 week. I don't know. So we are still didn't know what is the what is the actually the final answer from the university. Okay, so and for that, so for the assignment 2, the deadline, okay, the due date for the assignment 2 is actually before SEEE 2423 final exam. Okay, so before 2423 final exam, so submit through e-learning. Okay, so you can, if your group has completed the assignment earlier than the final exam, you can always submit. So but the submission link is actually not appeared yet. Maybe this week or maybe after this class I will create the link so you can submit through the e-learning. Okay. Okay. The second, so I have chat here. Uh, Study break. We don't know. We don't know. So we don't know actually whether you have a study week before the final exam or not. We don't know. We are still in what you call, we are still in a gray area, gray time period and so on. No need to. Okay, do we have to list down the reference in the mind map? Okay, so no reference needed to be listed. Okay, you just show the mind map only. Okay. Okay. So that is for the assignment. Very easy assignment actually. Actually, you need to present actually, but since we are in the middle of uncertainties, so I think we just uh, make it simpler. Okay. Okay. So So can we choose solar or wind by our own group? Okay, it's up to the group to decide whether you want to do a solar or wind. So I leave it to the group to decide. Okay. Okay. So that is for the assignment. And then for your test, second test will be, I think, next week. Okay. Test 2, the deadline is 10 January. I think 9 p.m. I think, if not mistaken, 9 p.m. There are 2 questions. Question number 1. So we go for the question number 1 first. Question number 1 will be power generation. Okay. So there will be coal generation. Okay, this one I think is 80% from the Q1. And then we have the hydro generation, which is I think 20%. I think not 80 lah. This one I think 90%. 90%. Most of the question will be coal, and another 10% is actually hydro generator. Okay. And question number 2 is transmission line, which is we haven't yet covered. We should have covered that last week, but since suddenly we have the suspension of the class, so we are not able to do so. So, but we will just focus. I will just focus on the uh, test 2. What the question that related to the test 2. Okay. So for the transmission line, we have one question only, which is a short line, which is actually a very simple short line, meaning that the transmission line is less than 80 kilometers. Okay, less than 80 kilometers. So that is transmission line, which is after this, you need to watch the video. I have already pre-recorded the video, so you need to just watch that. Okay, and then on our next class on Wednesday, we will do the calculation, example calculation based on this short line. Okay, for the short line, there are 2 elements that you need to always to highlight, which is the analysis on the voltage regulation, which is actually very simple actually, voltage regulation and also the efficiency, which is also very simple, which is you need to just calculate your P out over P in. Okay, so so this is actually the questions for your second test. Okay. Power generation, which is coal and generation, and hydro generator. And question number 2 is about transmission line, which is a short line. Actually, in the transmission line, what we will cover is actually short line and also medium line. Okay, so because short line, the elements inside the short line is actually different between medium line, because short line we model the transmission line as a resistor and inductor, but when we deal with the medium line, we have the resistance, we have inductance, and also we have a capacitance. So that's why we have a different, we categorize the transmission line under short line, medium line, and also there are another one which is long line, but this one that is not covered in this syllabus. Okay, so for your second test, we will only cover on the short line. And please be noted that for the topic that inside the test, it will be not assessed in the final exam. So meaning that you can ignore, or you can just, I think you can maybe just ignore the medium line, okay? Because it will be not be inside your final exam. Okay, I think that is the transmission, the announcement that I want to make. Okay, any question for the second test? Next week, okay? Next week. So make sure that you present. Okay. So so we continue with our class on this hydroelectric station, hydroelectric power generation. Which is actually a very simple actually and very straightforward. But I think, yeah, the student needs some time to adapt to the new parameters. For example, the cubic meters, any parameters, elements that actually very new to you. It's not very new. It's actually you need to refresh back. Okay. So actually for the, I think I have already shared with you. I hope you have already watched the hydroelectric stations. Okay. So for your test, second test, there will be no theory. Okay. There will be no theory. All are actually a calculation. So actually for the hydroelectric station, as we know, we have a water here, which is contained inside a dam. So, and then we have the, what we call the height. Okay. And then this is the weight. Okay. So the energy for the hydroelectric, which is we compute using what we call watt second. Okay. WS, watt multiply with second. Okay. Which is you can compute by using the weight of the water multiply the height. Okay. Of the dam. Okay. And then from the conversion of the water, so in it we have what we call turbine. This one is actually from potential energy, okay? Potential energy. So in Malay, it's actually tenaga keupayaan kan? Potential energy. So from here, we have turbine. So this one from potential energy. So we have turbine. So meaning that for potential energy, it actually convert into a mechanical energy. And then from the mechanical, we have a generator. From mechanical to electrical. Okay. So that's why we have this one. Hydraulic, meaning that it refers to the, from the potential energy to mechanical energy. We're using a turbine here. And then we have electrical, which is from mechanical into an electrical using a generator. Okay. So for this example, so the efficiency for this power conversion here is actually 0.85, while the efficiency for this power conversion is 0.9. Okay, this is what is actually meaning. Okay, so right now, what you need to do is to obtain the energy from the water, which is the weight of the water multiply with the height of the water. Okay, so right now the height is actually given, which is the head, which is 100 meter. Okay, so meaning that the height is actually 100 meter, and the water capacity is right now is been given 50 million cubic. Cubic meaning that cubic meter is actually meter power of 3. So we have 50 million. So 50 million is power of 10. Okay. So this one is actually meter cubic. Okay. So Right now we have the meter cubic, but right now we want to have the weight of the water. So the weight of the water, we actually refer to the equation, which is this one, 1000. Okay, this one, because this one is 1000 kilogram per meter square. This one is actually 1 meter cubic is equivalent to 1000 kilogram. Okay, 1 meter cubic is equals to 1000 kilogram. So for 50 million cubic meter, so how weight is the water? So we need to multiply. Okay, so this one we will obtain the weight of the water multiply with the this one is actually a gravity. Okay, gravity coefficient. So we obtain 4.9 power of 11 Newton. Okay, this one is Newton. Okay, so and then the total energy come from the water. So the weight multiply with the height. So we'll obtain 4.9 power of 13 watt second. Okay, so this WS is actually watt second. Okay, so but in electrical, we measured our energy in kilowatt hour. Okay, right? Kilowatt hour. So right now we want to calculate how many kilowatt hour in this 4.9 power of 10 power of 13 watt second. So what we need to do is 4.9 multiply 4.9 power of 13 divided by kilowatt hour 1000, and this one is actually how many second in 1 hour. So this one is a 3600 second. So this one is actually equivalent to kilowatt hour. Okay, so after calculate, you will obtain this one, 13.625 million kilowatt hour. Okay, because right now this is watt second, so we need to know what is the kilowatt hour units. So 4.9 power of 13 watt second is equals to 13.625 million kilowatt hour. So that is the energy of the electrical. Okay. So the efficiency, the total efficiency is actually you need to multiply. So you have this one. So 0.85 multiply with 0.9. So you will obtain the overall efficiency of this whole system. Okay, 0.765. So right now, the energy input from the water is 13.625 million kilowatt hour. Okay, so you have this one. I think this one I put E input. Okay, so we know that E input, sorry, E out over E input is equals to the efficiency 0.765, right? So from that, you will obtain your E output is equal to 0.765 multiply with 13.625 mega kilowatt hour. So we obtain 10.42 or mega kilowatt hour. So this is the output, electrical output from the dam. So meaning that from uh, 50 million cubic meter, and then the efficiency is total efficiency is 0.765. So the total output from the hydroelectric generator is actually 10.42 mega kilowatt hour. Okay. Please be noted that for your second test, I think the question is is actually a straightforward questions. Okay, it's straightforward question. So I think the style of the question will be, I think similar like this because since the reference is also quite limited, okay, and then the scope of the syllabus is also quite tight, so we consider the student don't have much time to actually explore this topic. So that's why we do the question to be very very straightforward. Okay, so I think we don't you don't have any problem if you can if you try this 2.3 and 2.4 example is enough for you to uh for the to be ready for the second test. Okay, so any questions regarding this example 2.3 before we proceed with 2.4? Okay, please be noted, right? Because the hydro station, the energy unit is in watt second. So you need to convert into kilowatt hour and so on. But for the coal, it is in calorie because we burn out the coal. So for the heat energy, it is calculated or measured in calorie. Okay. For the water dam, hydroelectric, the energy is uh, measured in watt second. Okay. So please be noted on that. So we proceed with 2.4. Okay, I give you time to look at it first before we discuss the solution. Okay. So for question 2.4 here, we have two questions. The first question is calculate the total energy generated by the hydro electric dam here. And then the second one is what is the drop of the water level? So this is the second question. When the generator is connected to a load with a capacity of not a capacity, it's actually a electrical load rated which is 15,000 kilowatt. Okay, and then supply the load for 4 hours. So what is the drop in water level of the dam? Okay, so we go for the first question first, which is the style of the question is similar to 2.3. Okay, so what you need to do is actually to have the total efficiency first, which is this is a very important part here. So you just need to multiply the turbine generator. Okay, they are because there are two power conversion here from the water potential energy into mechanical and from the mechanical into electrical. Okay, so the overall efficiency is 0.8075. That is the total efficiency of the hydroelectric generator, the total system. Okay. The second part that you need to do, okay, if you may be stuck and so on, I think this one is these two steps, these two what I call I think steps lah. So it's actually is a bonus marks actually if you start, okay, to proceed. So if you manage to get this and the total energy from the water, then I give you marks. Okay, please don't if you start, please write something. Okay, write something that is meaningful that I can give marks. Okay, so the total energy from the water, so you can just compute it by using the weight of the water multiplied with the height. Okay, so the weight of the water is given, the cubic, okay, the volume of the water, which is this one multiplied with the constant 1000 kilogram per meter cubic multiplied with the gravity. So you will obtain and then multiply with the height. So you will obtain the energy from the water itself in watt second unit is 2.4525 the power of 12 watt second. Okay, so the unit is in watt second, but since the electrical is actually in kilowatt hour, so we need to convert watt second into kilowatt hour, just like a coal, because for the coal we have a calorie, right? So you need to convert in all the calculation after you obtain, you need to convert into kilowatt hour. Same like for the hydroelectricity. For the watt second, you need to convert into its equivalent kilowatt hour. Okay, so it's given like this, the energy. So in kilowatt hour, so you need to divide by 1000 and also 3600 seconds. Okay, then you will obtain this one 681,250, or in other words, this one I think, yeah, it's quite difficult. So this one 6.8125 power of 5 kilowatt hour. Okay, kilowatt hour. Then you multiply with the efficiency, then you will obtain the output from the hydroelectric generator, which is 550,109 kilowatt hour, or 5.5 times 10 power of 5 kilowatt hour. Okay, so you need to do it, okay, because there are some trick steps here. Because when you deal with the calculator, so itulah takut you ada tersalah dia punya numbers dan sebagainya. Okay, so this one is kilowatt hour. So you need to do it yourself, then you know what I mean. Okay, so any question on the first question here, which is I think very straightforward. Okay, so if there is no question, then we proceed with the next question, which is if the electrical load is 15,000 kilowatt is connected to the station for a duration of 4 hours, obtain the drop in water level of the dam. So meaning that if you have a water, okay, because the volume, right? This is actually the volume, meter cubic. So this one 1 meter, this is 1 meter, and then another 1 meter. So this one panjang darab lebar darab tinggi So you have a meter cubic. So right now, what is the drop of the height here of the water level? Okay, when it is used to supply a load for 4 hours. So the total energy consumed for 4 hours. So right now, the power load is actually given 15,000 kilowatt. So if you want to know what is the total energy, so you need to multiply with the time. So right now is 4 hours. So just multiply. So you will obtain that the energy used is actually 60,000 kilowatt hour. So this is the total energy used by the load. Okay. So meaning that if the hours duration is higher, is longer, meaning that it consume more energy. Okay. So for 4 hours, 15,000 kilowatt load will consume 60,000 kilowatt hour. Okay, and then what next? Next is actually we want to calculate the amount of height of the water consumed. So let x is a variable which is the that represent the amount of height of the water consumed. Okay, therefore the total volume of water consumed for 4 hours is this one. Okay, so 2 power of 6 meter square multiply with the height of the water consumed. So where did I get this 2 and multiply 6 this one? So let's see from, okay, given here. So this is actually the area, the surface area of the water. 2 square kilometer. Is it 2 square? Yeah, 2 square. This one is actually 2 kilometer square actually. It's not square kilometer, 2 kilometer square. Okay, the area surface of the water is 2 kilometer square. So if you want to convert in meter square, so 2 multiply with 3 multiply with 2, right? So that's why I have to multiply power of 6 meter square. Okay? Because kilo, you need to multiply with 2. So that's why I got 2 power of 6 meter square. So that is the surface of the water. Okay. And x is actually the height of this water. Okay. So the total volume of the water is given this one. The area multiply with the height. Okay. So the energy of the water still, so this one is the volume multiply with constant 1000 multiply with the gravity. So this one is actually weight of water. Okay. 2000 2 power of 6 multiply with x meter cubic, which is the volume, multiply with the constant 1000 kilogram per meter cubic, multiply with the gravity. Okay, so this one is actually the weight of the water and multiply with the height, the head height, 50 meters, divided by, because this one is in kilowatt hour, okay? So you need to divide by 1000 and also 3000 under second. So that's why you will have this, the answer will be in kilowatt hour. So this is actually the energy from the water, 2,272,500 x kilowatt hour. X is actually still we don't know, which is the height that we want to find. Okay. And this one you need to you need to multiply with the efficiency. This one is your efficiency. Okay, so the total output from the hydroelectricity dam is 220.43 x kilowatt hour. Okay. So what is x? Because this one should must be equivalent to the total of energy consumed by the load, which is 60,000 kilowatt hour, which is we have calculated here. Okay, this is the total energy consumed, and this is the total energy come from the output from the dam. Okay, so this one 2,220.43 x kilowatt hour. So from here, we can calculate the X. So 60,000 divided by 220.43. So the answer should be 0.273 meter or 27.3 centimeter. Okay. So I think it's also straightforward, but the tricky one is actually to get the formula. Okay. So actually, it also start with this basic formula. The basic formula here. Okay, all start here, but you need before this you need to know the relationship between the energy of the load, okay, and then the relationship with the total volume and so on. Okay, I think that's all. Any question? Okay, so if there is no question, then you continue with the. I will upload after this the pre-recorded video for the short line, okay, for the transmission line. Okay, so and then on Wednesday we will discuss on several example on the short line. Okay, so thank you very much. I think that's all from me. Assalamualaikum and have a very good day.
Thank you, Doctor.